This is dangerous. This will be probably one of the worst severe weather outbreaks I will cover on my channel for Alabama. And it's going to be really bad. And I want everybody to know that whatever happens, I'll be here and I'll be live. Especially some certain people that I want to really know for them to listen to me that would live in like Huntsville, Riverton, Birmingham. I want everybody on Saturday to tune into my channel. I'll be live the whole day because Saturday will likely be one of the worst severe weather outbreaks of my lifetime. This is not an exaggeration, and I'm not going to put some crazy thumbnail on this video. I want everybody to take this as seriously as they possibly can. There's something that needed to happen for northern Alabama to get basically slammed by this severe weather outbreak. And storm modes are a little questionable, especially on the European model. However, models that deal with more severe weather and that are shorter range are showing a completely different story. And when we start seeing signs like this, and we start seeing the atmosphere set up in this way, if this trend continues for the next, say, 10 hours, then I can confidently say that we'll be under a high risk tomorrow, which would be, if you watch the Weather Channel, that would be like a Torcon of 9 or a Torcon of 10. And I know a lot of people, once I start saying all these things, are going to start comparing it to April 27th, 2011. But even though that comparison is close to what will happen, I think it's a little bit worse than what will happen. I think what will happen will be between April 27th, 2011 and March 2nd, 2012. Big days. These are days that left families in shambles, that destroyed everything, and I'm going to have to talk about it. Usually during spring, we get a setup kind of like this, but something very specific in the atmosphere, which now the models are confident on, is going to happen. I am confident that it will happen. If it doesn't happen, then our severe weather will only be a moderate risk, which is still ridiculous. That's a 4 out of 5. I think we'll be under a moderate risk. But overall, it's looking like that this thing is going to happen, and I'm going to explain it to you right now. So we're going to go to weather.cod.edu. I've been using it for years. Everybody, please use it. It's one of the most amazing websites. And we're just going to look at the models because that's all we have. And the first model we're going to look at is the GFS. Obviously, not the best or most short-range model. But what it's showing is one of the most concerning model runs I've ever seen in my entire life for Alabama. You get thunderstorms Thursday. And the reason why I haven't been doing videos lately is because I literally had to study this event. Thursday, you're not looking too ridiculous, just some light thunderstorm activity. And I'll show you a NAMST run of this where you can really see this activity. But you're like, wait a second. Why are the thunderstorms not blowing up in Alabama? Aren't we going to have good temperatures and stuff? Well, we'll take a look at it. Why are they not blowing up in Alabama? Because of this. What is this? This is temperatures that are going past the parcel path. And dew points dropping with height in this little bagged shape thing. This is called a cap. And right now, this model run is pretty strong. However, this cap on Friday, because it's going to get so warm and that warm air is going to transition aloft, that Friday will strengthen the cap. So why is this important? This is important because a massive area of low pressure is going to funnel an incredible amount of thunderstorms into northern Alabama that will all be rotating, including a little area of convection that will fly through Mississippi and Alabama. If this is strong and severe and is producing tornadoes, obviously I'll go live because there's still a chance of that. But look when I take a sounding. This is the reason why this outbreak will be so bad. When I take a sounding, alright, take a look. There's almost a cap. It's very close. So there's basically no instability. There's enough, and there's enough for supercells, and this event is still very concerning. But it looks like this convection, the atmosphere, look how fast it moves through. Look how fast. Bam, it's gone. Just like that, it's out of here. And as soon as these thunderstorms move out of here, and I take a sounding, the atmosphere in 10 to 15 minutes completely rebounds itself and goes from 50-something degrees to 63 over 60 with good instability, good honograph, and good severe hail numbers with a tornado hazard tag. With over 300 meters squared per second squared of effective shear, completely just, the cap blows off, right? Blows off its hinges. So, because these storms, and Jim Cantoria was hinting on this, because these storms take away that cap, the atmosphere in Alabama, Mississippi, Louisiana, or this area is extremely primed. And as soon as they move out, one of the largest, most dangerous tornado outbreaks sets itself up directly with the bullseye on top of northern Alabama. Right? That's not an exaggeration. That's just what it is. Directly. We become in the crosshairs, all right? Our temperatures. Yes, we're only at 65, 66. Actually, this looks like 68 degrees. But look at your energy values. They start to rise. You start seeing 1,000. Once you start seeing 1,000, you're looking pretty good. And look at this drop in dew point with height. That's going to support hail. Because hail, what's going to happen is it forms up here, it's coming down, and there's not a lot to melt it. The air isn't really that moist, and it gets to the ground a little bit easier. The temperature also drops pretty good with height as well. So you have very steep lapse rates. And then look at these. Look at these little guys starting to blow up and starting to develop. All right? These little niblets, all right, are very concerning. These could cause tornadic thunderstorms as well. All right, we go a little bit forward. We get hit with a intense niblet is what I want to call it. We get hit with an intense niblet. And this is kind of almost a little warm front that's lifting through that's going to farther strengthen the instability in our atmosphere. It gets knocked down a little bit because it's raining. Then again, this could still produce tornadoes with the honograph that we're seeing. But then once this niblet goes through, then again, now we're getting hit with supercells. Right? These are flying up in front of the area of convection. Now, the reason why I think this model doesn't really matter too much right now is because it's trying to see super far in the range as well. So we're going to have to use a shorter range model. But here we go. We're approaching 70 degrees. 66 over 62 now. Now we're almost capped. In fact, we're a little bit capped. Just, I don't know why. But we still have severe hail. That's a possibility. And we have a lot of shear. So any storm that's able to develop in this environment is going to be rotating. And then we get hit with, and you can see how broken and weird this line is. Probably going to be mixed thunderstorm development in a line like that. You see how this could be concerning. Okay. Now let's go to the Euro, which I don't want to do because it doesn't have a very good look at this event. Shows thunderstorm, which by the way, I don't think the thunderstorm convection will be this bad on Thursday. And then shows supercells, just right off the bat, just 3 supercells. You can see that these are supercells with the hooks and everything. 3 supercells right off the bat. We warm up and we're in rain for a long time, and then we just get this line of thunderstorms. All right? But we still have supercells throughout the day. Here's another one in Mississippi. If this were to happen, basically it's pick your poison. Will you get hit or will you not get hit? But at the end of the day, the GFS and the European model have become useless for this event. And the reason why is because they're not getting a good grasp. Obviously, the short-range models are beating them out. If you go to the NAM-ST, this is a good view of Thursday's convection. And look how different the story is. Look how different. 0 convection. Just rain showers. A little bit of some convection in Alabama and Georgia near Auburn. That's it. Gone. And your atmosphere immediately rebounds itself. And the area of low pressure that's powering all of this is up in here. Start getting winds veering out of the south. Look how quick. That's it. Our atmosphere completely rebounds itself. With, I may add, a cap in place. Yes, there's a cap in place. If this cap continues to be in place for just a couple hours, that's all it really needs to hinder the morning convection of Saturday. Which, if the morning convection, look how strong this cap is. It'd be very difficult to break something like this. Okay? Now, the HUR even has a better look at this convection. I haven't even looked at the HUR yet. This is the 48 hours. Yeah, the HUR shows a little bit more intense convection, alright? Obviously a more intense system, but doesn't show any of that impacting northern Alabama. So our atmosphere remains untouched. Mind you, places like, look, there might even be some supercells down here. This is still a concerning event. But, like I said, atmosphere is untouched. Alright, the NAM really shows this. The NAM is the only one that can really see this pretty well. That and another model that I'll show you. Right, simply shows the same thing, just showers, maybe more convection down here, Alabama and Georgia. Okay? Our atmosphere revamps itself. And that wave of thunderstorms moves in, and look, nothing. Just kidney beans. Just kidney beans. Little kidney bean showers that are rotating. That's it. Look how it comes in. It's ready to cause a ruckus, and then just nothing. Because, according to it, our atmosphere is capped. That's why there's no instability. It literally, air cannot rise to a certain point in this atmosphere because of this right here. See how that's touching the parcel path? Very close. But it's overall capped. You see how it's warmer than it is on the ground at a certain level. This is a capped atmosphere. So storms rotating, that don't cause anything. And you start getting good values exploding Mississippi. We take a look at our sounding after these thunderstorms have hit. Obviously the sun is just starting to rise. It's just starting to hit the ground, and our temperatures, even though we're still capped, start to warm up. It doesn't take much for that cap to break. But if this trend continues of just literally nothing in the morning, then we have no reason not to believe that this will be a terrible event for severe weather. National Weather Service agrees. But let's go to Tropical Tidbits because they have two models that I would like to look at. They have two models that would be lovely to look at, actually. And the first model is the NAM 12 kilometer, which goes out 84 hours. So you can get a better look at this. Now, obviously, this one's color table is weird. Like, yellow really is more intense. But as you see, with this Thursday system, nothing. Nothing on the NAM. And then nothing on this system. Nothing. So when you start to get the refiring of convection, we still have nothing. Which means our environment at this moment is so primed. It's incredibly primed. And obviously the dew point's well into the 60s. And this is just going to increase throughout the day. This would be extremely supportive of extreme convection, just ridiculous convection. And you start to see that developing. But this is going to be in Arkansas, Kentucky, and Tennessee. Our atmosphere just continues to heat up, right? Why would we stop heating up? So this would just, and look at 500 millibars if I can. If I look at, let's just look at the wind at the ground. Our wind starts ramping up out of the south. If we look at, I guess we could look at a forward wind combo at 250 millibars. Also starts ramping out of the south. A little bit change in direction with height. What we end up getting is you get, once these convection moves through, which literally will do nothing, by the way. Even in Florence, this will not impact their temperatures at all. It flies to the north literally in about 10 to 15 minutes. And then after that, this area is primed for supercell activity. Now, another model that could go out pretty far that's considered short range is Regen, which isn't the most accurate model, but you get more frames and it goes out 84. So I don't know exactly what this model really does. It's always bewildered me. But as you see, look at these Thursday storms. So it's good convection in Texas and Oklahoma. Literally, not a single drop of rain for us. Which is what, if you want severe weather, and obviously the convection in Alabama and Georgia, if you want severe weather, that's a bad sign. Here we go. It shows this stronger, which First of all, this is concerning on its own, just because it shows that these storms really strong, which I would have to go live for that. And then shows us in rain a little bit more. And if we look at, can I put up dew points or anything? That's why I hate tropical tidbits. Our temperatures, as you see, are lower, 67, but they're warming up, and then, all right. Let me open up pivotal weather. There has to be something I can look at, just to convey to you that the overall trend is that because Regem is not a very advanced model, it doesn't really consider caps and stuff. So, can I get one that just, these are all great models, can I just get like an 84-hour one, like with the NAMs? I can't do that. But I can look at the icon. Let's see what the icon says. Why not? The icon is a model too. Let's make it a forecast loop. The icon is German, so in all fairness, Germans, though they don't deal with tornadoes a lot, because, I mean, we have some good things here to look at. We got dew point, we got wind barbs, we got temperature, we got some stuff. Let's look. So shows right off the bat the Thursday system. Nothing. Alright? Actually, let me just take this forward like this. Shows this system a little bit more of something there. But we get clear skies, and then we get hit with whatever this is later in the day. Now, I'm not too good, but let's look at the temperatures. The temperatures will be something good to look at here. All right, 53. When did these storms actually... I need to remember. Let's look at our cape. Let's look at mixed layer cape. Why not? So here we go. Your Thursday event. We have some cape. This event, the icon really shows nothing. Icon does not show this cape getting far eastward enough, and we basically get a bust. Alright, which is still on the cards, but short range models, the NAM disagrees. They're saying capped atmosphere. And if you want severe weather, you want your atmosphere to be capped. And finally, what I'm going to finish off with, and anybody can do this, but we're going to look at the NWS severe weather outlook, just so I can sort of show you where the threats are. Alright, we look at, like I said, the day that we're looking at, which is day 4. Alright, day 4. And you can see where this 30% is. This is where your highest risk of severe weather, and they still include Madison County. So you have to watch out for this event. It's looking worse and worse. And if the atmosphere is capped, which is just the general idea, and it doesn't explode like what the icon is saying, then this will be an interesting situation. I think that we'll have a lot of supercells. I don't think it's comparable to April 27, 2011. Just check back in for more updates.